Okay, so Leetcode practice time. So two goals in this video. The first one is to see how to solve this problem. So find a solution, and then we are going to do some coding work. And the second one is to see how we should behave in a real interview. Suppose this is something given in a real interview. So let's get started. Let's see. All right. So Facebook has used this question before. Remember the first thing, the first step always is to try to understand the problem. If there's anything unclear, please bring up the questions to have the interviewer clarify, and also think about the edge cases at the very beginning. So let's see, random pick index. So given an array of integers with possible duplicates, randomly output the index of a given target number, and you can assume that the given target number must exist in the array. Alright, so the size of the array can be very large, so a solution that uses too much of the actual space will not pass the judge. So yeah, so it doesn't say that whether the input array could be empty or not. So if it is empty, I think then I'm not sure what we should return. So let's assume that the input array, the input array won't be empty. So we don't need to consider that case. Let's make this assumption. So the second one is to see how to solve this problem. So after you fully understand the problem, you know what the edge cases are, you clarified everything, then it's time for you to find the solution of for this question. So for this one, I would say the first solution I could think of is that we could use a hash map. We could turn the input array into a hash map. So the key would be the number, and the value would be a list of the corresponding indexes of the number. So in this one, for this solution, the constructor is going to take all of n is the length of the input array, and for the pick, it is just going to be all of 1, which is constant operation. So it says, but since there's no says that the array can be very large, and it doesn't want us to use too much of the extra space, so then we have some extra concerns about it. So remember, for this question, there is a pretty well-known algorithm called random reservoir. So the general random reservoir is described in this way. So you have n numbers, and you want to pick k numbers from it, from n numbers randomly, and each number, the probability for each number to be chosen is n over k. So sorry, the probability is k over n. So probability for a number to be chosen is k over n. So, and also you need to say that k is smaller or equal to n. So the process is like this. So first of all, you will have an array, let's say ARK. So you fill in the ARK with the first first k numbers from the array. So let's say we have ARN, which contains n numbers, and we are going to pick k numbers and insert them into ARK. So we are going to say I from let's say 1 to this is 1 to k. So we are going to say, alright, so ARK I is equal to ARRN. So in this description, I just use 1-based index instead of 0-based index, which would be easier for me to just describe this general algorithm. And then for the rest of the numbers, so we have the j is from let's just reuse I, so I from k plus 1 to n. So at this moment we pick a random number j, pick j within 1 to k plus, within 1 to I randomly. So if j is smaller than or equal to k, then we just replace ARR kj with the current number. Otherwise, you just if j is larger than k, we just throw it away. So this is essentially how the algorithm works. So the reason why each number is has the equal probability to be chosen is because suppose it is a random number j. Suppose ARR, and let's take AR and j. So to see the probability for this number to be kept in the final array. So if j, let's say if j is larger than k, so for the first time, the probability for it to be chosen is k over j. And the next time, the probability for it to be kept is actually 1 minus so you have 1 over j plus 1. So you have 1 over j plus 1 of the probability for this number to be replaced, and you have 1 minus 1 over j plus 1's probability for it to be kept. So similarly, the next one it to be kept is 1 minus 1 over j plus 2, so on and so forth, until you have 1 minus 1 over n. So you can see that this one, 1 or k divided by j, and then this would be j over j plus 1, and similarly this is j plus 1 over j plus 2, so on and so forth. The last one is n minus 1 over n. So you could see that this j, we could just do some simple calculation to see that the final answer is actually k over n. So similarly, you can have some we can follow similar process to justify that if j is smaller or equal to k, the probability for the number to be kept is also k over n. So having said that, the runtime for the constructor is going to be constant, because you don't actually need to do anything. And for the pick, the runtime is going to be linear to the length of the input array. So having said that, let's do some coding work on this approach, because it's a bit more difficult than the last hash map solution, and also if it's the assumption that we cannot use too much of the extra storage. So let's see coding. So for coding part, we care about the speed and also the correctness and also the readability of the code. So let's give it a shot. So for the solution, we are going to define a member. Let's call it nums. This dot nums is equal to nums Alright, so that finishes the constructor. So for the next one, we are going to pick the numbers. So let's see. So we are going to just have one numbers, which means we are going to pick one number from the n numbers. So first of all, let's see. I'll say count is equal to 0. So for the first time, you need to have alright, so actually we need to initialize count as 1, and the corresponding index, let's assume it is equal to -1. So you're going to say, okay, for I is equal to 0, I is smaller than nums, or we just use, we don't use we need to use the index best, because actually we need to return the index. So smaller than nums the length plus I. This is the index, and if target is equal to nums I, so that's the time we have found. So if it is not equal to this, then we just continue. So this can save us some indentation and make the code to be more readable. So then after this, it means the target is we find a target number. So we are going to call, okay, so actually we can just return, we can just define random here. Let's say this is ran. So ran is equal new random. Okay, so we're going to say new so int random is equal to, let's call it random, so let's see, code random number is equal to random dot next int with count. So I need to see whether the random exclude or include the number random next int. Okay, so seeing the JDK next int, so next int return the next, so uniformly distribute the int value between 0 to the specified value drawn from this random number generator, between 0 and okay, so it is inclusive. If it is inclusive, then we need to say count as equal to 0. So if random num is equal to 0, then we are going to set the index as I, and finally we are just going to return index. So that's pretty much it about the implementation of the random reservoir solution. So you have pick target. So first of all, initialize the random, and also we assign the reference of the array to be a private member, and also when you call the pickup, we first initialize count as 0 when index as -1. So if target is equal to the, if not equal, then we continue. Otherwise, if it is equal, then we generate the a random number between 0 to the count. So for the first time, you're going to for sure to generate random number as 0. So and next time, the probability is 2 plus 1 for it to replace it, and yeah, so on and so forth. So we are just following a similar procedure similar procedure for the random reservoir. It's a little bit special because we just need to pick one number from the random reservoir. So let's give it to run. Remember, the last step is always to do some testing. So testing, usually if it is not a runnable platform, you will need to go through a simple example explaining how this piece of code is gonna work, and at the same time do some sanity check on the code. And after you're done with that, you could use set some extra test cases to have good enough test coverage. But I would say for this one, let's simply go through the example first. So let's say we pick 3. So first of all, count is x equal to 0, index -1. So the first 2 integers are not we are just going to continue. So when alright, so I think I found a bug. We need to plus the count. So for the first one, the probable, we are going to just generate random number from 0 to 0, so we are going to replace the index and we plus the count. For the next time, count is equal to 1, we are going to generate a random number between 0 and 1, and then if it is 0, then we replace the index. For next time, you're just going to generate random number 0, 1, 2, and then yeah, so if the random number is 0, then we have the index to be replaced. So I think overall it looks fine. Let's give it a shot. Okay, so this is a typo. Next, int. So bound must be positive, which means okay, so the any index should be open, I guess. Yeah, so yeah, it's pretty. It says that int value between 0 and the specific value. Okay, so the specific value is exclusive. I think I just overseen that. I didn't pay attention to that. Exclusive. So let's do a submission for it. Alright, so I think we are good with this solution. And that's it for this coding question. If you have any question, feel free to leave some comments below. And if you like this video, please help subscribe to this channel. And I'll see you next time. Thanks for watching.